Okay, in this video, I would like to introduce aerial photography filtration. Okay, specifically, I'm going to introduce two color theories and how to use these theories to make filters. Okay, usually there is at least one filter in front of the lens of camera system to filter out um, specific colors, specific light with different colors to make sure that the light energy, the electromagnetic radiation received by the camera is the one we want. Okay, so color theory is based on the foundation of something found by Isaac Newton in 1666. He laid the foundation of color science when he discovered that actually white sunlight was composed of a mixture of all colors of the spectrum. So he used this prism to what? To divide the white sunlight into different colors, or you can say different types of light with different colors. So that's the very foundation of color theory. And this is the fund of Newton actually indicates that white color is a combination of all colors, of light of all colors. Okay, so color theory. So color is a concept to human beings. RGB. It is actually a psychophysical response through normal human eyes to the visible region of electromagnetic spectrum from about 400 nanometer, which is violet or blue, to 700 nanometer, which is red wavelengths. You should know that visible light, this concept, is defined for human beings. For other animals, they have different, say, um, they have different vision abilities. Some of them, they may say a wider range of electromagnetic spectrum. Some of them may be even narrower than, some of them may have even narrower range of electromagnetic spectrum that they can identify. But for human beings, the visible light range is from 400 nanometers to 700 nanometers. That's us, right? So there are two color theories. The first one is called additive color theory. So when you are following this theory, you assume that white color consists of all the colors in visible bands, and black is the absence of all colors. This is actually what Newton found, right? White light is the combination of all light with different colors. So in additive color theory, red, green, and blue, RGB, they are called primary colors, and other colors can be produced by combining these three primary colors. And on the other hand, cyan, magenta, and yellow, they are called complementary colors. Cyan, magenta, and yellow, they are complement colors of red, green, and blue, respectively. Okay, so here we have some formulas. How to produce different colors. If we combine red, green, and blue, okay, together they form white. Okay, and if we combine only red and green, we have yellow. And yellow is the complementary color of blue, right? So once we have yellow, we add some blue, eventually we have white. Okay, if you combine pure green and pure blue, you have cyan. And cyan is the complementary color of red. So if you add pure red on cyan, you have white again. If you combine pure blue and pure red, you have magenta, and the green is the complementary color of magenta. So based on magenta, if you add more, not more, you add pure green, eventually again, you have white. So now the concepts here you need to know. Firstly, for additive color theory, primary colors are RGB, and the complementary colors for RGB are cyan, magenta, and yellow. Okay, this concept of complementary color is pretty important because later you will know that this is important to the what? To the producing of filters, of different filters. Okay, here is another figure showing you the additive color theory, right? Primary colors of additive color theory are RGB. So this theory is based on what happens when light is mixed. When we're looking at our TVs, when we're looking at our computer screens, TV screens and computer screens, they are producing different colors using additive color theory. Additive color theory. Okay, so since there is additive color theory, there is subtractive color theory. It is based on the use of pigments or dyes and not light. So it is used when we paint or work with filters or we print something. Okay, it is also based on the use of complementary color dyes. So what are the three complementary colors of RGB? Cyan, magenta, and yellow. Okay, they are also called subtractive primaries. So because it's subtractive, okay, if you subtract cyan from white, you get red because cyan is a combination of green and blue, right? So if white is a combination of RGB, and if you eliminate G and B, which is cyan, from white, you get red. Okay, so the next two formulas, they are similar to the first one. If you subtract magenta, which is a combination of blue and red, from white, you get green. If you eliminate yellow, which is a combination of pure red and pure green, from the white, then you have blue. Okay, okay. So again, if you eliminate magenta and cyan from white, you get what? You get yellow. And yellow is what? Yellow is the combination of red and green. So you can see here, it's just a change of relationship. This subtractive color theory still assumes that white is a combination of RGB. The difference is that you subtract some components from white to get the rest component. Okay, so here are subtractive primaries, cyan, magenta, and yellow. Here, the complementary colors are portrayed this way. For example, we have primary color blue here. Its complementary color is yellow. So yellow is on the other side of this figure, or yellow is facing blue but has no common field with blue. Similarly, cyan is the complementary color of red. It has no common ground with red and is facing red. Green has a complementary color, also has a complementary color. It's magenta. Magenta has nothing to do with green. It's facing green, right? So here comes the filter part. A filter with a specific color can filter out its complementary color. So here we have RGB, three colors. And we have a yellow filter here. And the yellow filter can filter out, or you can say yellow filter can absorb its complementary color, which is blue. So after this yellow filter, we can only receive red light and green light. Blue light, unfortunately, it has been blocked or filtered, or you can say absorbed by this yellow filter, because blue is the complementary color of yellow, or you can say, usually we say that yellow is the complementary color of blue. It's the same, right? So this is how we use subtractive color theory to produce, to create filters. And filters can be used to filter out some light with specific colors that we don't want, okay? Okay, here is a comprehensive figure to show you the color formation. Okay, on this circle we have R, we have G, we have B, which are the three primary colors of additive color theory. We also have what? Cyan, magenta, and yellow. They are subtractive primaries. Okay, additive and subtractive colors are complementary. Okay, so magenta is the complementary color of green, right? Cyan is the complementary color of red. Yellow is the complementary color of blue. So this is a very clear illustration of additive color theory and subtractive color theory. Okay, so now we can talk about filters. So a filter can be placed in front of the camera lens to filter out certain wavelengths of light. And in visible light range, different wavelengths indicate different colors, right? Before they can reach the film plane and expose the film. So if we don't want blue light reach the film, what filter should you use? You should use a yellow filter, because yellow is the complementary color of blue. Yellow filter will absorb, or you can say will filter out blue light. Okay, after that filter, only green and red light, because the blue light has been filtered out, right? So here, let me ask this question. So here we have red light, we have green light, we have a blue light, but here green light has been blocked by this filter. So what is the color of the filter? So of course, the color of the filter should be the complementary color of green, which is what? Magenta. Magenta, the complementary color of green. So the mechanism here is very simple, right? We have three primary colors, RGB. If you don't want one or even two of them, obviously you should leave at least one of them, right? If you filter all of them out, you just block all of them. You don't even need a filter with a specific color, right? But when you want to filter out one of them, use a filter with the complementary color of that primary color here, right? If you want to filter out green, you use a magenta filter. And next step, you can add another filter here to filter out what? Red or blue. If you want to use the second filter to filter out red light, what should you use? You should use cyan filter, because cyan is the complementary color of red. Again, if you add a third filter with what? With yellow color, then blue light will also be filtered out, and eventually no light can reach the film. It doesn't make sense, right? Why do you even do that? But yeah, the theory is just like that, okay? Okay, most aerial photography is required using at least one standard filter. So, for example, for natural or true color aerial photography, we use something called HF, haze filter. It is usually used to absorb light shorter than 400 nanometer. It's in the range of violet, very close to blue. So usually we don't want so much blue light to expose the film. Okay, and color infrared, for color infrared aerial photography, a yellow filter is used to subtract almost all the blue lights. Okay, shorter than 500 nanometer. So usually blue light and also violet, they are not that welcome in aerial photography. Okay, I will stop here, and in next video we're going to talk about films. Different films can be used in different scenarios, in different applications. Okay, and they have different actually structures. Okay, a film can be very thin, but as thin as they are, actually there is microstructure inside each film. Okay, for different applications. I will talk about that later in the next video. Thank you.